Hey, good morning, guys. We're going to be back with section or lesson 19.1 today. We're looking at understanding quadratic functions. Today's lesson is going to include a video and then me doing some whiteboard problems, and then you'll have a Google Docs document to either print or look at, and then from there either you'll write the answers down or write them right on the paper or on a line sheet. Either way is what I'm trying to say. And then you'll take a picture and send that attachment back to me. This is the way today's work will be done. So let's get started. We're going to see a little video first.
So we think of the classic quadratic function, y equals x squared, we can actually get any other quadratic function by transforming just that one, by shifting, moving over, maybe multiplying through, scaling, and so on. Let's take a look at some quadratic functions that aren't the parent standard one. G of x equals 1/4 x squared, h of x equals 3x squared, p of x equals negative 5x squared, q of x equals 7/2 x squared, f of x equals negative 3x squared. Well, you notice that they all sort of have the same flavor to them. The only difference is that we are changing the a's. We're changing the multiple, the constant that we're putting in front of the x squared. So what impact does that have? Well, it turns out the impact of that is it makes the parabola either more tightly narrowed or more bowed out like a gentle bowl. And it turns out that if we think about it, we can figure out how the coefficient should affect the narrowness or the wideness of the parabola. And it turns out it's actually counterintuitive. So let's think about it. If we take a look at multiplying, let's say in this example, the standard function, x squared, by 3, what happens? It means that, well, every value that we currently have, like this value right here, is going to be multiplied by 3. It's going to go up, and now it's going to be here. So what's going to happen is that point's going to be way up there, and so really, it's going to tighten. So when we put a big number here, it's going to tighten the parabola, which seems not to make sense at first inspection, because you're thinking, wow, making it smaller. But don't think of it that way. Think about taking a point here and moving it way up. So tightening it makes it more dramatic. So when you have a big number here, drama. Now, when you have a small number here, for example, if you put a quarter in here, well, then you take the usual parabola, and instead of being this height, we're going to make it a quarter of the size. So now it's going to go from here way out to here. Yeah. Sort of less dramatic. So small number, less dramatic. Large coefficient, drama. Now, armed with that, we can actually see which is the most narrow and which is the least narrow. And of course, we're going to ignore the negative signs. We're just going to look at absolute values, because really the negative sign just tells me if I'm a happy face or a sad face. It has nothing to do with the drama. So really we just take the absolute values, and if we wanted to actually order these functions from narrowest to widest, then what I want to do is put in absolute value the coefficient that's the largest, and then have them decrease. And therefore I'm going from narrowest to widest. So in absolute value, I see that 5, the absolute value of negative 5, is the world's champion. So this is the most narrow. So I'm going to put that here. Then the next most narrow, what's the next biggest, largest number in absolute value? It's going to be 7/2, which is 3.5. This is merely 3. So this is going to be the next one. Then for third place, notice there's a tie, because of course we're only looking at absolute values. So in fact, the function h of x equals 3x squared and f of x, which equals negative 3x squared, both have the same wideness or narrowness. They're just opposite, opening up one and the other. And then finally, the most boring, or the most gradual or gentle, or however you want to spin it, is going to be the g of x function, which is 1/4 x squared. 1/4 x squared. So now you can see from narrow to wide, different parabolas.
All right, so first I'm going to go through one with you where the A is going to be positive. function of x, or y, equals ax squared in this case, right? Okay, so anyway, the a is positive, it's 2. So the way we'll start here is to make a little t-bar, pick some values that are close to the origin, -1, 0, 1, 2, and -2, and then plug those guys in. So you can start with 0, 0. 0 squared is 0 times anything is going to be 0, and that's our vertex, 0, 0. Let's try the ones. -1 in place of the x, -1 squared would be 1, positive 1. 2 times 1 gives us 2. Now, we talked about exponents before, and what they do, they give us a curve, don't they? They give us a curve in the graph. So when I put 1 in place of the x squared, it's going to give me the same value that I had when I had -1 in there. See, because in both cases, 1 or -1 squared is going to be a positive value. So 1 squared is 1 times 2 gives me 2. Now, take your 2 and plug it in. 2 squared is 4 times 2 is 8. And then like we just said, excuse me, -2 is going to have the same y value, -2, 8. So there's your graph. Okay, it's a narrow stretch. All right, the vertex is 0, 0. The line of symmetry is the y-axis. Okay, and the vertex is a minimum point. So the minimum value is 0 here. Okay, now let's suppose we made the a value negative this time, -1.5 x squared. All right, so here's your values. I'm not going to go through each one again, but I did pick values again kind of near the origin, -1, 0, 1, 2, and -2. And when we place those into the equation, okay, you see what the y values are that are the output, right? Now, what is different than the previous graph is the a being negative. Now we're going to see a downward trend. Okay, so this is going to go downward. All right, and again, our vertex is 0, 0. You see it's a stretched, narrow graph. Okay, and again, the axis of symmetry is our y-axis. Okay, this vertex is a maximum point now. So maximum point 0, 0, there it is. It's the highest point in that graph. And that's how you deal with a negative value for a. All right, so I think you have enough information now to work on the sheet that'll finish section or lesson 19.1. Again, go through and do those either on a separate paper or on the paper, print it out and do it right on the paper. Shoot me back a picture of your work, and I'll give you credit for it that way, okay? Any questions during the day, I'm available by email till about 1:30. Have a great day. Storm Tower.